So now let's start with the alkanes. So if, for example, you have CH3, CH2, 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 CH3. Now, what is the name of this compound here? You're going back, I'll tell you that we are starting from the beginning. So, but it's going to be a rundown. So we have 1, 2, 3, 4, 5. 5 carbon atoms, and they're all single bonds. Now, the 5 members of the alkane is called what? Pentane. So the name of this compound is called pentane. It's called what? Pentane. So you want to stick to the end of this video here because, like what I said, it's a total rundown of how to name organic compounds. Here we have what? Pentane. So the first rule when it comes to what naming organic compound is what? Take the longest continuous carbon chain. Just take the longest continuous carbon chain. Now, for example, here we have this one CH3, CH2, C, CH2, CH2, CH2. Now, let's look at this compound here. So, remember 1, 2, 3, 4, 5, 5 pentane, right? Now, how do we name this compound? Now, the good say that take the longest continuous carbon chain. Now, when suppliers see this kind of structure here, the first they will do, they will take from here to here. You get, which is going to be wrong. So let's count from here to here. How many carbon do we have? Let's count from here to here. How many carbon do we have? And let's count from here to here. How many carbon do we have? This we are to what? Know the longest continuous carbon chain. Do you understand? So 1, 2, 3, 4, 5, 6. Here we have what? Hexane. So here we have hexane. Because the 6 members of the alkanes is what? Is the 18, right? So let's say from here to here. 1, 2, 3, 4, 5, 6, 7. Look at what? Here we have what? 18. Right? So, but now let's say from here to here. 1, 2, 3, 4, 5, 6, 7, 8. Look at what? 18. Do you understand? So now the parent name is going to be the one that have the highest numbers of carbon atom in the chain. So from here to here is what is 18. Do you understand? So this is the correct one. These two are the what wrong one. Do you understand? So now that is what the first step. Now, if you step from here to here, I have a substituent. I have what is substituent, and this substituent belongs to the alkyl group. Now, we have got the alkyl group, which you have got the methyl, the ethyl, the propyl, the isopropyl, and you get to display on the screen here. You have to know the different type of alkyl group, so that when you see them, when it comes to the naming of the organic compound, you will just recognize them and what name them. You understand? So here we have what is substance. So now we now know our parent chain, and we know that it has got only one substance. So how do we go ahead name this compound? Now, what you want to understand here is that this compound, this carbon atom is what is carrying what the carbon atom, right? So the word substance, right? So in nomenclature, this carbon atom, the numbering, this one must have the what lowest possible number. Do you understand? So when I start from here, 1, 2, 3, 4. Count number 4 is what is carrying what the substance. Do you understand? Count number 4 is what is carrying substance. But when I start from here, 1, 2, 3, 4, 5. Count number 5, that what is carrying substance. So can you say that we have two possible numbers of what carbon atom that carry what substance. I count number 4 when you start from here, and I count number 5 when you start from here. So here going to be 4. This is what I call what? Ethyl. 4 ethyl. Then here we have what? Octane. 4 ethyl octane, right? Now we start from here. 1, 2, 3, 4, 5. 5 ethyl octane. Now, if it's an objective exam, these two will be in the options. Do you understand? These two, you see, these two are the options. Now, but what is the name of the correct? What is the correct name? My correct name is that the carbon atom that carry the substance must have the lowest possible number. Here we have 4. Here we have 5 because 4 is the lowest. So this is the right one. This is what you want to do. So the name of this compound is called 4-ethyl octane. Do you understand? So let's look at on that one. So how do we name this compound here? If you are being given a structure like this to name, how do you name it? Therefore, you want to follow the rules. Take the longest continuous carbon chain, right? Take the longest continuous carbon chain. Now, if you take the longest continuous carbon chain, if you come from here to here, how many carbon do you have? From here to here, how many carbon atoms do you have? You get from here to here, how many carbon atoms do you have? Now you want to what count from all the possible end to end so that you can know the numbers of carbon atoms, right? So 1, 2, 3, 4, 5, 6, 7, 8. Here we have what octane, right? Octane. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we have none. What possible ways can we name it again? 1, 2, 3, 4, 5, 6, 7, 8. Octane. Then 1, 2, 3, 4, 5, 6. So now, no matter how you do it here, none is going to be the highest, the one with what highest possible, highest carbon atom. Do you understand? So none is the parent chain. So from here to here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So from here to here, we have what the parent chain. Now you find that this is not counted among the chain. This is not counted among the chain. This is not counted among the chain, and this is not counted among the chain. Do you understand? So now, when you take your parent chain, then you are able to know substrate that are attached to what the parent chain. So those side chains that are not counted among the parent chain are called substituents. And here we have 4 substrates. 1, 2, 3, 4. 4 substrates. Now, the name of this guy is called ethyl. Ethyl. The next one is called isopropyl. So now you need to check. You need to check common alkyl group. Here you have isopropyl. Now here you have bromo. And here you have chloro. Are you there? Now, what you want to do here is that you must number in such a way that the summation of the position of the substrate must have the lowest possible number. Now, let me say that again. Now, when you have 2 or more substrates attached to the parent chain, now how do you number it? You number it in such a way that when you sum the position of the substrate, you are going to have the lowest possible number. You understand? So now, if I start my number from here, therefore I'm going to start my number from here. Then sum all the position of the substrate. Then I'm not going to start from here. It's very important to do all things so that you can confirm the right position I want to follow when naming. So here we have 1, 2, 3, 4, 5, 6, 7, 8, and what? 9. Right? So if you follow from here, I can number 4 I have an ethyl, so it will be 4 plus. I can number 5 I have a bromo. 5 plus. I can number 6 I have what? An isopropyl. Here we have 6 plus. I can number 7 I have what? Chloro. So when you sum that position, what are you going to get? 22. So 4 plus 5 plus 6 plus 7, what do you mean? 22. Just and that is when I start from this point here. Now, what about if I start from this other point? So let me remove this one. So let me start from here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here we have 3 plus 4 plus 5 plus 6. So what is number? In sum them together, I'm going to give you what? 19. So 3 plus 4 plus 5 plus 6 is going to give you what? 19. So that's when I start from here. But when I start at this point here, give me what? 22. You could say that the summation of the position of the substrate must have the lowest possible number from the norm grid. Do you understand? So because this one gave me what? 19, which is the lowest compared to what? 22. Lowest is the guy, 22 is what you want to go. So this is going to be the correct what naming norm grid. So this is going to be what the correct number, right? So now let's start naming the what? The substrate here. So I come back 3, I have what? 3 chloro, right? I come back 4, I have what? Isopropyl. So you have 4 isopropyl. 4 what? Isopropyl. Then I come back 5, I have what? Bromo. So maybe 5 bromo. Then I come back 6, I have an ethyl. So it will be 6 ethyl. Now, what is the parent name? The parent name is what? Is non-name. Can you see that? Parent chain is no name. Now, so if you want to name it here, you must arrange here alphabetically. You must arrange the word substring alphabetically. So the parent name will always come last. Do you understand? So B will come before C, and C will come before E, and E will come before I in alphabetical order. When you arrange it in alphabetical order, so it would be five, five boom. There we have it. Three what? Three glue. There we have it. Six ethyl. Six ethyl. There we have it. There we have four iso. So let me remove this place here. Four isopropyl none. So that is the name of this compound here. So with this, you should be able to what name any compound related to what alkanes. So we have done from simple to what to the complex. So it's just for you to what keep on practicing and master. If you have any situation under the alkene, can leave at the comment section. I will respond to that. So the next one I want to look at is what the nomenclature of the alkene. How do you name this compound here? So now let's focus on the nomenclature of the alkenes. Now alkenes, they all have alkenes have what double bond. So whenever I see a double bond in an organic compound, is an alkene, right? So let's look at this other one here. Now how many carbon atoms do you have here? Here we have 1, 2, 3, 4, 5, 6. Here we have 6 carbon atoms. Now 6 carbon atoms know a lot eggs, right? Now when there's a double bond, you now see in ENE. So that's why I say hexene. So the name of this guy is going to be what? Hexene. Hexene. Right? Because there's a double bond. Same to this guy here 1, 2, 3, 4, 5, 6. It's going to be what? Hexene. The same with this guy, you're going to be what? Hexene. Can you see that? Now, but you find that the position of the double bond are not the same. Here is at this carbon atom here. Now, what you want to understand here is that when you're naming organic compounds, the functional group must have the lowest possible number. Do you understand? The functional group must have the lowest possible number. So here we have this double bond here. The double bond should have what? The double bond should have what? The lowest. The double bond should have what? The lowest possible number. I So these two carbon are the one carrying what double bond. So if I start from here, 1, 2, 3, 4. Carbon number 4 is what carrying double bond. But when I start from here, 1, 2, carbon number 2 is what carrying double bond. So now, you go say that the carbon atom carrying double bond must have the lowest possible number. Of course, 2 is lesser than what 4. So it will be 2 hexene. That is the double bonds are carbon number 2. Now, if you want to do that, you can say all eggs 2 in. Now, I've found this one because this one is simply explain the nomenclature very well. Eggs means 6 carbon atom. In means what? In means what? It have a double bond. Then number 2 that the double bond is account number what? 2. That is meaning. Now, these are going to be account number 1, right? So going to be 1 eggs or eggs 1 what? In. Can you see that? Then you are going to be 1, 2, 3. 1, 2, 3. So whichever way you start knowing from, you're going to be 3. So you're going to be 3 hexene or eggs 3 words in. Do you understand? So you say that when you have a double bond here, the double bond must have the lowest possible number. Now let's build it up. Building it up. Now we have a structure on the board. Now, what is the name of the compound here? You get. Now, do you say that? Now, whenever I have a double bond here, the double bond is going to be of my priority. Now, the rule say that take the longest continuous carbon chain that contain the double bond. You get. So when I start from here, 1, 2. How many carbon atoms do we have here? Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, suppose you're going to take from here to here as the parent chain, which is 9, and it's going to be wrong. Then the reason why, from here to here, do not include the double bond. The double bond start from here. Oh yeah. So this is what my double bond here. So if you like, let the chain be 100 and it does not contain the double bond, that is wrong. You understand? Now, I must start from here. So when I start from 1, 2, 3, 4, 5, 6, 7, 8, it's 8. So 8 carbon that contain double bond. So eighth chain, the 8 carbon chain that contain double bond is what is the parent chain. Rather than 1, 2, 3, 4, 5, 6, 7, 8, 9. Hope you understand. So from here to here, you do not include double bond. You get, but from here to here, the double bond is included. So you must tell me what the longest condensed carbon chain that include the double bond. You understand? So if you have 1, 2, 3, 4, 5, 6, 7, 8. So you have octene. You have what? Octene. Do you understand? Now, irrespective of, because from you take from here to here, I have three substances. Here we have ethyl, methyl, and what? Bromine. Here we have bromine. Here we have what? Methyl. Here we have what? Ethyl. Can you see that? Do you understand? So, irrespective of what, no matter what, carbon atom, no matter of substance, you understand? Now, this carbon atom that carry double must have the lowest possible number. So, your number will go to start from here. So, if you have 1, 2, 3, 4, 5, 6, 7, 8. Can you see that? 1, 2, 3, 4, 5, 6, 7, 8. So now, yeah, gamma 1 is what is kind of double bond. So it will be opt 1 in, opt 1 in, right? So this is called the parent chain. Now, I come back to our ethyl group. So it will be 2 ethyl, 2 what ethyl. Now I come back 5, I have what a methyl and a bromine. So we have what 5 what methyl. And here we have 5 what bromine. Can you see that? So B become 4 E and E become 4 what M. So arrange it alphabetically. Here we have 5 bromine. Here we have what 2 ethyl. Here we have what 5 methyl. Then up 1 in, up to what 1 in. So that is me. Do you understand? So please, if you are following this video here, please leave in the comment section that you are following this video here. So now, like when I say, it's going to be a complete video on what nomenclature of the organic compound, right? So this one is the alkene. Now, let's look at another one. Let's look at this structure here. So pause video and check if you can what name this compound here. Pause the video. So let's look at it very well. Now, 1, 2, 3, 4, 5, 6. Going to be what? Eggs. Eggs, right? Eggs. So now let's look at the position of the carbon atom. We start from here 1, 2, 3, carbon what? 3. 3 what? Eggs, right? And we start from here 1, 2, 3. You also want 3 eggs. Do you understand? 3 eggs. So that means the position of the double bond is not the problem. You get? So now, because when we come from both sides, getting 3 eggs, 2 eggs, fine. So we are now going to use what? Your substrates. You're now going to sum the substrates together. The one that give you the lowest possible number will that be what the right number. Do you understand? Because yeah, either side will give me what 3 eggs in. So the double bond is no longer the problem. So yeah, we are now going to use what? The substrates. Do you understand? So now let's start from here first. Let's see when we sum that position, going to what is going to give to us. So here we have 1, 2, 3, 4, 5, 6. So 3 plus 5. 3 plus 5 equals to what? 8. Guys, so 3 plus 5 is what? Is 8. So when we start from here. Now let's start on the other side. Now let's start on the other side. Here we have 1, 2, 3, 4, 5, and 6. So 2 plus 4. 2 plus 4 equals to what? 6. Do you understand? So in this say that start from here, give me what? 6, but start from here, give me 8. So the one that start from here will be the what? Correct numbering, right? So now The number is going to be what? 2 chloro, right? So it'll be 4 bromo. Can you see that? So B will come before C in alphabetical order. So the name is going to be what? 4 bromo. Then we have 2 chloro, right? Then we have 3 what? Hexene. Or you can say X 3 in, or you can say 4 bromo, 2 chloro, X 3 what in. Just that each of them they are correct. Just stand now. So learning about the alkane, nomenclature of the alkane. How do you name this? Here we have 1, 2, 3, 4, 5, 6, 7. Here we have what? X, right? Now, because there is a double bond there, it's going to be I. So it's alkane. It's alkane. Y-N-E. It's alkane. Y-N-E, right? So it's going to be, now, here it's going to be what? 1, 2, 3, 4, 5, 6, 7. So it's going to be heptane. Heptane, right? So going to be a time. But what is the position of the double bond here? Now, what you want to understand here is that alkyne is the same thing with the alkene because of nomenclature. There is no difference. The only thing here is that is what YNE and the what triple bond. Just and so it's also follow the same pattern to that of the what alkene. So what happened to the alkene also happened to what to the alkyne. So here we have 1, 2, we're going to be 2 heptane or hept. So So going to be 1, 2, 1, 2, 3, 4, 5, 6, 7. So going to be heptane, heptane, right? Heptane. Now, hep means what? 7 carbon. En means what? En means a double, a triple bond, right? But what the position of what of the double bond? 1, 2. It was about the lowest possible number. Look at something here. The nomenclature of the alkyne follow the same thing of the alkene. The only difference here is that is YNE and what and the triple bond. Every other thing remain the same. So here we have 2 heptane or hept 2 what I can you see that? So from here I can start adding what you can start adding what your substrates, right? Your substrate and the rest. I'm moving what the moving the triple bonds. So now let's look at another one here so that you understand better. This compound here. So you can pause the video and see if I can name this. Pause the video and see if I can name this. Okay, pause the video and check if you can name this compound here. So how do you name this compound? So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be decyl, right? Decyl, decyl, right? So these 2 carbon atoms, they are the one that will carry what the triple bond, right? So therefore, let's pick the position of the what triple bond. And before you can start naming any other thing here, you must therefore pick what the position of the what triple bond. So from here, 1, 2, 3, 4, 5, carbon 5, right? But now here we have 1, 2, 3, 4, 5, carbon 5. 1, 2. Are you serious? So now let's name this one. What is the name of this compound? So what is the name of this compound? So you can see that this compound is what is an alkyne because it contains what it triple bond, right? So therefore, let's take what the longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be what? No 9. No 9, right? No 9. Now the next one we want to do here is that so what? Number is such a way that the carbon atom that carry the triple bond must have the lowest possible number. So if I start from here, 1, 2, 3, 4, 5, carbon 5, right? Right? Carbon 5. So here you can say 5 nonene, right? Now let's start from here. 1, 2, 3, 4. Okay, here we can say 5 no 9. 5 no 9. Sorry, 5 no 9. So but let's start from 1, 2, 3, 4. Here we have 4 no 9, right? So this one that have 4 is the correct number. So you have to start from here. 1, 2, 3, 4, 5, 6, 7, 8, and what? 9. Can you see that? Now, here we have a methyl substituent. Here we have what? A chloro substituent. Here we have what? Isopropyl. Can you see that? Iso what? Propyl. So in alphabetic order, which for confidence, C become before what? I, right? And I become before what? N in alphabetic order. Just so chloro, iso, and what? And methyl. So how do you name it here? So it will be 3 chloro, 3 chloro. There are what? 7 isopropyl. There are what? 2 what? Methyl. 2 methyl what? 4 no 9. Or you can say no 9 4 non 4 I non what? 4 I. So this is the structure of this order one here. So this is what name alkyne you get. So alkyne is not that different from the alkene you get. Therefore, know the numbers of carbon atoms that know the numbers of carbon atoms that were in the parent chain. Do you understand? So the next one we want to look at is what is the alkanol. The alkanol functional group. How do you name the alkanol functional group? Okay, now let's look at what the alkanol functional group. How do you name alkanol functional group? Now, whatever alkanol, then it have what OH. So now whenever I see an organic compound with OH, you know what alkanol. Alkanol. And the nomenclature is not different from the one we have named. And as a matter of fact, the only thing you have to do is what? Is the OL. Do you understand? So how many carbon atoms do you have here? 1, 2, 3, 4, 5, 6, 7, 8. Now it's supposed to be 18. 10, right? Now, but since there's OH here, the E will play what? OL. Right there. So the name of the alkanol is derived from the corresponding alkane. When you remove the E, the ending E, and you play what with OL. So you have alkanol. Do you understand? The same thing here. Now, the functional group must have the lowest possible number. Do you understand? So when you're naming, the OH must have the lowest possible number when you start the numbering. So when I start from here, 1, 2, 3, 4, 5. Here we have 5 heptanol. Or you can say all 5 O. Do you get that? So these two are the same. Is that what you say 5 heptanol or hepta 5 O? Do you get that? But when you start from 1, 2, 3, so the carbon atom that carry the OH is our carbon 3. So you have 3 heptanol or hepta 3 what O. This is that. So this is the correct one. Do you understand? This is what is the correct what name. So now let me remove something here. What about if you have something like this? CH2, CH3, right? Probably you have something like this, Cl, right? Probably have something like this, Br. So how do you name it here? So just a little adjustment here. Now, irrespective of the numbers of what substrate I have, that the carbon atom that carry the OH must have the lowest possible number. Do you understand? So the number should what favor what the OH, not the source strength. So here we have, so we're going to start from here. 1, 2, 3, 4, 5, 6, and what? 7. Right? Now, so which is going to be what? 3 heptanol. 3 or hepta 3 what? All right. Now, B will come before C and C come before E. Right? Bromo, chloro, and what? Ethyl. Arrange them alphabetically. What do you get? So going to be 6 chloro, 6 what? Bromo, 6 bromo. Here we have 2 chloro. There we have 4 ethyl. Just 6 bromo, 2 chloro, 4 ethyl. What? Then we have hepta 3 what? Oh. So this is name. This is name of the organic compound. Just so if you are following, please leave at the comment section that you are actually what following what I'm doing here. So I will give you one for you to try. Leave one for you to try. So go ahead and try this for me. Leave it at the comment section. Leave at the comment section. Go ahead and try this for me. So I'm not going to name some here. You really want to try it for me. Leave it at the comment section. I want to see what you can do. So that is for what nomenclature of nomenclature of alkanol. Now the next one I want to look at is what ketone and aldehyde. So ketone and aldehyde, they both have the same functional group. So let me show you how to name them. So now look at what aldehyde and ketone. How do you name an aldehyde and ketone? First of all, understand that structure. So they both have the same functional group. Here we have REM. So here it's called is an aldehyde. Aldehyde. So now here we have a ketone. Now you can see that both have the same functional group. If you call it carbonyl functional, if you check very well, both have one of the same functional group. So this is called an aldehyde, this is called a ketone. Aldehyde. Now, but aldehyde and ketone are just like a common name. So what is systematic name or when to point what the I part name? Now the I part is called now what Alkanal. Alkanal. Here we have what Alkanone. Do you understand? So now they both have the same functional, but they are not the same compounds. Do you get that? Now this carbon atom here, the functional is always at the starting point or at the extreme. A good example we have CH3, CH2, 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 C. Right there. Now, this is what is functional group here. Now, and in alkanal or aldehyde, the functional group is always carbon 1. 1, 2, 3, 4, 5. Right there. It's always at the carbon 1. Even when you have something like this, CH3, CH2, 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 CH2. Right there. Yeah, the carbon atom is still carbon 1. Right there. So that when you're naming an aldehyde, understand that, or when you're naming what alkanal, understand that the functional is always at carbon 1. Right there. So when you're naming, the position of the functional is not actually needed because you already know that it's always carbon 1. So you have 1, 2, 3, 4, 5, 6, 7. Understand that the position of the functional here in alkanal does not really matter because it's always at the extreme point or at the end point. You understand? So what is the name of this guy here? Here we have 5 carbon atoms. So what to be what? 18. But you have what? An alkanal functional group. An alkanal functional group that is called pentanal. So it's going to be pentanal. Pentanal. Not one pentanal. Please understand here. Not what? One pentanal. Do you understand? It's not one pentanal. It's called pentanal. Now, how many carbon atoms do you have here? 7. So going to be what? This is going to be heptanal. Heptanal. Do you get that? So the position of the substance can I come in now? When I have what? When I introduce what substituents, you get. So the name of the alkali is not that too difficult. Therefore, understand that once you see functional pair, that is the carbonyl that carry what an hydrogen atom is not alkali. Now, but on the other hand, we have something like CH3, CH2, C. You understand? Now we have something like this here. Now, this function in a ketone is not always at the carbon, so you can move it. Do you understand? So that's why the position of this function matters a lot. If I have something like this, CH3, C, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 6, 7. Okay. Now we have something like this. So now, yeah, you can see that the portion of the ketone changes. Here going to be account number 3, here going to be account number 2, right? So how many carbon atoms do we have? 1, 2, 3, 4, 5, 6, 7. So going to be heptanol. So it's being derived from the alkane. Alkane, when you remove the word the E, I play what O-N-E. O-N-E, call what heptan, you call what alkanol, right there. So since here you got 7 carbon atoms, so you got to be what heptanol. Heptanol. Now, but the position of the position of what of the function of is account number 3, right? So going to be 3 heptanol or hepta or hepta 3 what or this that. So you can see the difference between this guy and this guy here. So what about this one here? You're going to be what? You're going to be 2 heptanol or hepta 2 what on. Can you see that? So that's why the position of the double the position of the functional pair matters a lot. Now they both have the same functional, but yeah, the difference is that this in the alkanol, the hydrogen is not attached to the carbonic functional, but here hydrogen is added. So please differentiate between these two things here because students normally have issues naming structures like this. So now let's start building them up. Let's look at this compound here. Let's look at these structures. So here's what is an alkanal functional, right? Alkanal functional. So here we have 1, 2, 3, 4, 5, 6, 7. Although you can pause the video and see if you can try it and if you're going to get the same answer as that. So you're going to be heptanol, right? Heptanol. Now, but here we have a chloro, ethyl, methyl, and what methyl, right? Then you can see that this compound contains 2 methyl group. So the parent is called heptanol, right? Now I can number 3 have a chloro. So here we have 3 chloro, right? There are what 3 what methyl, 3 what ethyl. So here we have 3 ethyl. Now these two are the same compound, So it's going to be 5 5. So it's going to be dimethyl. Going to be what methyl. So when I have 2 the same substrate in a chain, you have to use the prefix di. Di means what 2, 2, 2, right? 2 substrates. So now it would be 5 5 dimethyl. It's okay. Now let me say this here. Number and number are always separated by what? By comma. The number and alphabet are separated by what? Hyphen here. Do you understand? So C will come before what? E, and E will come before what? N. Do you understand? So we're going to do what? 3 chloro, right? 3 what? Ethyl. Then 5 5 dimethyl heptanol. So that is what is name. So there's no any other way you can start naming this thing here. So just for you to look at structure and master it. So let's look at what for the ketones. For example, here we have CH3, CH2, C. Okay, now look at this other one here. So you can quickly pause video and try this yourself and see if you're going to get the answer. Remember, this is what functional pair, right? So it will be 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and what? 9. Right? So the name is going to be what? Nona 3 on. Do you understand? So it's normally no na no, right? No na no, no na no, right? Now, but here we have the functional pair. Functional is account number 3. 3 no na no, or no na 3 words on, right? So here we have a chloro and ethyl, the di to methyl group, right? So it will be 6 chloro, 6 chloro. Here we have 6 words ethyl. They have 5 dimethyl. Non na 3 on. That is what the name of the compound. Do you understand? So if you are following up to this extent, please leave in the comment section that you actually what are following. If you understood or you actually get what I'm saying here, please leave in the comment section that you're following. Please don't forget to give me a like and a comment. It's very, very important to be able to do this. So you can also share this video. Share this video with your friends. Share this video with your classmates. Share it in all your various groups. It's very, very important to do this.